Well, if you've repaired any amps at all, I guarantee one of these ones has been on your bench. This is the Fender Hot Rod Deluxe, and it's gotta be the most common amp in the world. It's a tube amp, although it has a solid state rectifier, and it's sort of loosely based on Deluxe circuitry, but very loosely. It's much different. It's got, master volume, and it has an overdrive channel and all of that, and an effects loop. So it's really only by name related to the original Fender Deluxe. This one literally fell off a truck. Literally. So it's really road worn. And a friend of mine picked it up for dirt cheap. We're going to see whether we can get it working. I might be working now, who knows? But it's definitely going to need some work. I note that this input jack has been pushed in. It's a PCB attached jack, so those are always a problem. Anyhow, let's see what we can do. I've worked on a number of these. They're a pain in the rear end to take apart. Okay, so we have it hooked up to a signal generator. Man, this thing's filthy. And we have it going through a light bulb limiter, just in case there's a short, and a variac, and also just for fun, an isolation transformer, just because that's always hooked up. And let's see whether we can get, turn it on, see whether we get any. Oh yeah, so we've got something coming there. I can see the pilot light coming up. I'm at 40 volts. Let's see whether the tubes are going to start lighting. I'm going to give it more than 40 volts to get the tubes lit up. We're at about 80 volts now. Those heat, yep, the heaters are coming on. Huh. All right, let's see. Well, there you go. So the amp works. So the thing about Hot Rod Deluxes is they have a design flaw, and it's amazing that in all the various iterations of this amp over the years, they've never fixed that. And it's these two power resistors right here. You can see these have been replaced because, and I don't know if you can see the charring around them and around these diodes here. Probably not. I'll bring the camera closer. You can see around here, and then there's a diode in here, and you can see the around under there that's been cleaned up a little bit, and then this resistor over here. And the problem is these power resistors are used to drop the voltage to, I think it's 15 volts, which are used in the relay circuit to switch between the drive channels. So these overheat because in the original design, they're right against the board and there's no cooling, and they generate an awful lot of heat. And so they overheat, they lose their connection to the PCB. Oh, sorry about that, folks. They lose their connection to the PCB, and your switching circuit suddenly stops working. Extremely common problem. So I see someone has already repaired this, replaced the resistors, and lifted them off the board to get a little bit of airflow there. Looks like those are the original IC caps, which are crap. But if they're not leaking, we'll probably just test them and leave them in. Anyhow, well, it works. That's amazing. Oh, and let's take a look at that jack. Right. Where's the broken jack? Right there. So the jack is there. No, let's show you. The jack is right there. So the jack is there. It's still attached to the PCB by the looks of it. And it may be just pushed in a little bit. We'll see whether we can pull that out. Otherwise, we'll just have to replace it. These are insanely loud amps, by the way, or at least in the first few settings of the volume control. They are like crazy loud. That's with the master down. And I think we do have a little bit of noise on some of the pots. So that master control is not doing anything right now. Maybe that's a channel. Yeah, there we go. I'll have to clean up these pots, test them, and you know, I'll ask the owner if he wants to, sorry about that, quiet. I'll ask the owner if he wants to repair that jack or not. It's working, but you know, obviously after time it's going to create some issues. Well, no surprise at all, you can see here on the positive lead of this cap, it has started to leak. And also on this one, there's just a little bit there. So this 47 microfarad, this 22 microfarad, we're going to replace all of these. There's one over here as well. They're not visibly leaking, but they're garbage. All right. Okay, so we'll start by testing the tubes. And of course, this is two 6L6 power tubes from the tube store in this case. And they say that they're a matched pair. So first we're looking for leaks within the tube. And let's test here. Good, good, good. And now we're going to test for a leak between the cathode and the heater, which is, this meter's going to go way up there and then we'll drop down when we press this button. And it's great, no problem. So no leaks. So now we're going to test for power. And it's good. It's 115 or so. No, sorry, it's 103. So that tube is great. And we'll see how closely matched the other one is. Of course, for real matching, you have to do more than this. This is just a quick test of power. Oops. Oh, this one's funny. There we go. And same thing, we're going to test for leaks. Let it heat up a little bit. And that's all great. And then we'll test for power. Just a little under the other one, it's about 98. Okay, so here are the end results. The two power tubes, 103 and 98, those are great. The preamp tubes, which are of course are dual triode, are 96 and 87 for V3. That's fine. 92 and 125, so not very balanced, but still fine, and 93 and 98. So the tubes are all okay. Okay, so it's been a few days. We've received our order of our replacement filter caps and our input jack. And now comes the fun part. So one of the reasons why I really not that fond of working on Hot Rod Deluxes is because of this PCB. Now, if I were really stupid and lazy, I could just clip out these caps and tack in the new ones using J-hooks, but that would be very dumb. I mean, there's 450 volts running across these. So we definitely don't want to do that. I mean, there might be some circumstances, like if you were just replacing a resistor or something that only has a low voltage going across it, you might want to be able to do that without taking the PCB out. But in this case, we certainly have to remove the PCB, which means, thank you Fender, we have to remove all of these knobs, all of the washers. We have to remove these 6 screws. We have to remove this ground wire. And then gently but firmly pull down the PCB so that we can get the shafts of the pots under this lip without breaking these ribbon cables that I really hate. So, thank you, Fender. Well, let's get at it. Whoa, look at the work that's been done there. All right, let me show you that. So somebody's done some work on those traces by the by those power resistors. All right. Well, let's get at it. So we'll start by removing the old caps here. Alright, okay, so it's really just a matter of getting at it from this side, giving it a little bit of tug. There we go. And this guy's probably glued in, is it? Yeah, it's glued in too, so. Alright, I'll have to remove that glue too. Alright, next up. Well, the reason these are so hard to get out is, of course, they were glued in. I should have thought of that. Silly. So we have to try to cut through the glue here. There we go. In this case, we're actually cutting through the can. There. Oh, that was fun. And onward and upward. Okay, so first thing, we're going to replace that input jack. And I've removed the other one. I have the new one in. And I like to tape, when I'm working upside down like this, I like to tape the components on just so that I'm sure they're not going to move too much. And they're going to stay in position. All right. Okay, here we go. Crazy about that one. Get my glasses on here. Ooh, this one here's got some cold solder joints on it too. It's not good. Fix that up. Yeah, these guys are okay. It's never a bad idea to check for continuity as you go. I don't know where this guy's going. Yeah. Okay, it looks like we're good. Okay, Fender. To complete this game with glue, that's what we're going to do. We'll use some glue. And of course, we are going to be observing the polarity. All of these have the positive lead going down to the bottom. So we're going to make sure we follow that. And for the sake of the next person in here, we're going to make sure that they can see the values on the capacitors. Okay, so here's the 47 microfarad cap. I'd like to do is put some more glue on these, but my glue is not working very well, unfortunately. And that happens, you know, uses too much. Starts coming out this side. So we'll see what we can do. So the last thing I do before I put this back together again and see if it works is to clean off some of that flux. And I use 99% isopropyl alcohol for that, which works well. Okay, now because I was replacing filter capacitors, there's a very real chance we could have a short here. So I am starting up with a light bulb limiter and a variac, and we will see whether anything blows up. Okay, I'm at full voltage now. Let's see what happens when we turn the standby off. Okay. Got some sound. Scratchy pot though. Forgot to fix those. All right, let's try it with the guitar. We're trying our new input jack, and as usual, this amp is loud as hell. Let's try the channel switching here. Watch your ears. Sorry, the guitar's out of tune. All right, more drive. Yeah. Bright. Channel. Okay, I think we're good. I'll probably clean those pots though, and I might set the bias. I wasn't really happy with the glue, so I decided to use some hot glue. So I think those are in there quite a bit more securely now. And away we go. Okay, so I cleaned the pots, and now we will test the bias. I'm not plugged into the light bulb limiter because that will affect the voltage. So we're just going to let the tubes warm up a little bit, and Fender quite conveniently provided us with a handy little test point here, bias test point, which will include the bias for both tubes. So combine the bias for both tubes. So typically Fender biases out of the factory cold. So it'll probably be about, well, I think 60 millivolts will be fine. And let's see what we're at. This will be combined, of course. We're at 61, yeah. So you know what? I'm going to leave it at that. I think that's just fine. So there we go. We're done.